All right, here we go. First video lecture of the year on preparing solutions. So you can reference the pages in your book. I thought it was 35 to 38. If you need some help, this is just a little bit of a description and some examples to help you get through this whole solution maze. So here are some definitions first. Solutes are the dissolved parts. Solvents are the liquid. Usually we're going to use distilled water, and it's really important in our situation to use distilled water so that there's nothing else in it. Concentration is kind of like density. So the higher the concentration, the more stuff is dissolved in the solution. So here's where concentration gets a little bit confusing and where we need our math. Concentration is described in a lot of different ways. Percentages, ratio, proportions, parts, molarity, normality. It can be confusing, so we're going to look at how a few of the common ones are calculated. So if we're going to calculate percent solutions, we're looking at based on a percentage of the solute, so that's the liquid part, in a solution using the concept of per 100 parts. So a 1% solution has 1 part of the solute and 100 parts of the solvent. Sorry, that should be solvent. So these parts can be milliliters, grams, any measure of volume or mass. They're expressed in two different ways. You can do a mass per volume or a volume per volume. You just have to watch your units. So the mass per volume description tells you how much of the solid is dissolved in the solution. The volume per volume tells you how much of a liquid is dissolved in the solution. So here's a mass per volume example. So a 5% mass per volume sodium chloride solution have 5 parts of sodium chloride for every 100 parts of solution. So to make 100 milliliters of this 5% solution, you're going to weigh out 5 grams of NaCl, and you're going to first dissolve it in about 50 milliliters of water. Then, after all the salt is dissolved, you're going to raise that total volume to 100 milliliters, and this is called bringing to volume. And it's done to prevent going over your volume. So if you just measured out 100 milliliters of distilled water and then put 5 grams of NaCl in it, you would have a larger volume than a 100 milliliters, so that would not be a 100 milliliters of the solution, so it would not be a 5% solution. It would probably be a little less. So now what do you do if you have to prepare a 5% solution that's not a multiple of 100? Any ideas? If you said use a proportion, you're correct. So let's say you need just 37 milliliters of 5%, and we'll do a sodium chloride solution again. So you set up a solution and you're good. So 5 grams out of 100 milliliters is a 5% solution. So how much is that out of 37 milliliters? So it's 1.9 grams of sodium chloride dissolved in 37 milliliters of water. So you can use this example, you can come and look back at it over and over again to help you figure out. So let's say I wanted to make a 5% volume-to-volume solution. This is actually a little bit easier. So you've got a 2-propanol solution, which is just isopropyl alcohol, and it has 5 parts of 2-propanol for every 100 parts of water. So to make this, you pour 5 milliliters into a graduated cylinder, and then you just bring it to volume again. And again, what if I only need 37 milliliters of this 5% 2-propanol solution? And yes, you just do a proportion again. Why am I always using 37 milliliters? I don't know, because it's an ugly number and I want you to not be afraid of it. Okay, so what if I don't start with a 100% solution, which is actually going to happen a lot? Percent solutions can also be referred to by a ratio or a proportion. So you can call a 1% solution a 1 to 99% ratio or a 1 to 100% solution. And a 25% solution can be referred to as a 1/4 or a 1 1/4 solution or a 1 to 3 ratio, since there's only 1 part of the solution and 3 parts of the other. So here's the deal. Whatever you choose, just stick to it. So whether you choose the molarity, the percent solutions, whatever you choose, just stick to it. Okay, so let's take a look at concentrations. So let's say you have a percent solution and you want to make it into a less dilute solution. So you start off with a 50% solution, or you might see it as a 50x solution. You might see that. You might even see, a 5 molar solution, and you want to make it less. Usually your stock solutions are a lot more concentrated than your final solutions. So all you're going to do is use this handy-dandy C1V1, which is concentration and volume, equals C2V2, which is the final concentration, which is what you want, and how much of that final solution you want. So here's how that looks. Let's say you need 50 milliliters of 70% alcohol and your stock solution is a 95% solution. What do? You can use the C1V1 equals C2V2. So just look at it. You have 3 out of the 4 variables of that. You have your 95% alcohol, which is your C1. You have your 70% alcohol, which is C2. And you have what you want, how much you want out of it at the end. So you have 50 milliliters. So what I do is I just do some math. So 70 times 50 divided by 95, and I get around 37. So I measure out 37 milliliters of my 95% alcohol solution, and then I bring it to volume. That's what we're going to describe here. So I want you to try this next one on your own. Now it says calculate the volume of a 50x TAE solution needed to make 2 liters of 1x TAE solution, and you're actually going to use this a lot. So I want you to go ahead, describe how to make that solution, bring it to class, and we'll talk about it before we start our quiz. When you have the C1V1, you can also substitute that with molarity, because M1V1 is the same thing as M1V1 equals M2V2 is the same thing as C1V1 equals C2V2. So reference your book, try a couple of the practice problems in there, try the TAE problem on this page, and we will talk tomorrow about any questions you have before the quiz.